So this is question 1 from exercise 5C from your textbook. So we've got two events, probably of A is 0.5, probably B is 0.2, and probably they happen together is 0.1. So I'm using the standard formulas, and I'm using the probability of A or B is equal to probability of A and probability of B minus that overlap. So if I substitute into numbers into this formula, probability of A is 0.5, probability of B is 0.2, and then we subtract them happening together, 0.1. So that's quite simple, and the answer to that is 0.6. So on to the second part. Now I prefer at this stage to do the Venn diagram and then just pick all the answers from the diagram. So I've placed the overlap of 0.1 into the overlap. If A is 0.5 and 0.1 of it is in the overlap, 0.4 will be here. With B being 0.2, 0.1 in the overlap, so the other bit to make up 0.2 must be there. If we add our probabilities together, we're going to get 0.6, which means outside of A and B will be 0.4. And that should get us through the rest of the questions. So probably I'm not in B, will be the 0.4 there and the 0.4 there, which is 0.8. Probably that I'm in A and not in B would be this bit here. I've got to satisfy two conditions. I'm in A, but I'm not in B, so I can't have the 0.1. 0.4, and then finally I'm in A or I'm not in B. A or not in B, so this will be. So I can be in A, which is 0.5, and I can be in B, which is 0.4. So it comes out as 0.9. Okay, question 2. So for the first question, we've got to find out probably that of A intersection B. So I write out my formula. I put in what I've been given. So A or B is 0.6, and this is going to equal probability of A, which is 0.4, plus the probability of B, which is 0.5, which means our overlap is going to have to be, as this comes to 0.9, and these are going to be equal, our overlap must be 0.3. So the answer to the first question is 0.3. Now I'm going to put the information into a Venn diagram. So hopefully you can realise why that's 0.3, 0.1 and 0.2. Just as you've seen in the previous question, you put the overlap in first and then make sure your A altogether comes to 0.4 and your B comes to 0.5. All of that adds up to 0.6, leaving 0.4 outside of A and B but inside the rectangle. So probably that I'm not in A is going to be 0.6. Okay, you don't actually need the Venn diagram for that, you can just do 1 minus 0.4. Probably that I'm in A and I'm not in B, so I can be in both conditions for part C. So probably that I'm in A is 0.4, and then outside of B is another 0.4. So the two, so you can be in either, okay, it's an either situation, and we add them together, it's 0.8. Okay, and finally for part D, I am not in A or I'm in B. In B is 0.5 and not in A is 0.4, so that comes to 0.9. That's that question done. Okay, so I've done my Venn diagram as per usual, and I'm going to start off by putting in the intersection of C and D as 0.15. Now if D is 0.4, then this will be 0.25. The probability that I am not in C and not in D is 0.1, so this goes on the outside. So we can now work out probability C on the basis that all our probabilities must add up to 1. So we've got 0.25 and 0.15 comes to 0.4, plus 0.1 is 0.5, so we must have another 0.5 left here. So that fills in the diagram completely, which should enable us to answer all the questions. So for part A, probably I'm not in C and I'm in D, so go with colour here. Okay, so I'm not in C and I'm in D would be this bit. So we're going for 0.25. Then, if we go to our next bit, for part B, I'm in C and I'm not in D would be this bit, 0.5. C altogether will be 0.5 and 0.15. 0.65. And finally, not being in C and not being D. Well, it's interesting that they ask us this question because they've given us that answer there. So that would be 0.1. And that's your first 3 questions done.